replacing wiper blades.
Objectives. At the end of this video, you shall be able to remove the wiper blades and wiper motor assembly from the vehicle, dismantle the wiper motor assembly, clean and inspect parts, assemble the wiper motor and test, refit wiper motor assembly and blades on vehicle and check for operation. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainees toolkit 1 number, test lamp 1 number, screwdrivers, multimeter, equipment required. Running car 1 number. Materials required. Cotton waste as required. Soap oil as required. Wiper blade as required. Emery sheet as required. An automobile wiper motor is a device that powers the windshield wipers, clearing rain, snow, or debris for visibility. It is typically located under the vehicle's hood, near the windshield, and is controlled by the wiper switch on the dashboard. The motor moves back and forth, activating the wiper arms and blades to sweep across the windshield, improving driver visibility in various weather conditions. Task 1. Remove the wiper blades and wiper motor assembly from the vehicle. Loosen the wiper blades fixing bolt or screw. Pull out the blade assembly from the milling. Disconnect the wires from the wiper motor. Disconnect the operating lever or cables. Loosen the mounting bolts and nuts. Remove the motor with the extending arm. Task 2. Dismantle the wiper motor assembly, clean and inspect parts. Remove the gearbox cover fixing screws and lift the cover. Remove the circlip and the flat washer. Remove the gear, assembly and connecting rod. Remove the through bolts from the motor housing. Remove the housing carefully and place it vertically. Remove the armature from the gearbox housing. Clean the dust and dirt from all the parts by using a nylon brush and cloth. Testing motor field winding armature brush and brush tension spring. Visually check the gear wheel teeth for damage or wear. Replace if necessary. Task 3. Assemble the wiper motor and test. Before assembling, lubricate the following parts: gear, wheel and wound with grease, and the armature shaft bearing surface, bearing bushes, gear wheel shaft and crank pin with SAE 40 oil. Refit the armature to the housing. Ensure that the thrust disc and the felt washer are in place. Place the armature through the housing and tighten the through bolts with the gearbox mounting cover. Fit the gear and plate assembly with the bush. Fit the connecting rod with the flat washer and circuit. Connect the connecting rod and pin fixed in the cable rack assembly. Fit the gearbox cover in its position and tighten the fixing screws. Testing. Measure the supply voltage by connecting the wiper as shown. Switch on the motor and measure the voltage between the motor supply terminal and the good earthing point with the voltmeter. If the reading is low, check the battery cable connections and the panel switch. Disconnect the cable rack and measure the no load running current with an ammeter connected in the supply line. Carry out no load test. Connect the wires to the motor and effect supply. Check at what voltage and motor starts functioning at no load. For a 12-volt system, the motor should start running from 4 volts. Check the cable rack. Check the maximum force to move the cable rack by hooking the spring balance. The maximum permissible force is 2.7 kilograms. Check out final checking. Test the wiping speed of the motor. It should be between 45 to 50 cycles by minute. Task 4. Refit wiper motor assembly and blades on vehicle and check for operation. Place the motor in its place. Tighten the mounting bolts and nuts. Connect the wires to the motor. Ensure that the gearbox spindles are in the correct position by switching on and switching off an allowing them to come to rest at the end of the cycle. Fit the arms and blades to the splinter driving drums on the gearbox spindle at the correct parking angle. Press the headpiece until the retaining clip sound is heard to snap over the end of the drum. Switch on and note the wiped areas. If necessary, change the position of the arms by removing and refitting them in the appropriate position. Do not attempt to turn the spindle by hand force.
Recap. In this video, we have discussed how to remove the wiper blades and wiper motor assembly from the vehicle, dismantle the wiper motor assembly, clean and inspect parts, assemble the wiper motor and test, refit wiper motor assembly and blades on vehicle and check for operation. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Perform troubleshooting and remedy for windshield wiper and washer, no operation, intermittent operation, continuous operation, and wipers will not park.
Hello, I hope you are all excited for today's session. In this module, we are going to learn how to perform troubleshooting and remedy for windshield wiper and washer no operation, intermittent operation, continuous operation, and wipers will not park.
Objectives. At the end of this video, you can able to identify the defects in wiper motor and blades. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainee's toolkit, 1 number. Screwdrivers, multimeter. Equipment required. Running car, 1 number. Materials required. Cotton waste as required. Soap oil as required. Wiper blade as required. Wiper motor as required. Wiper nozzle as required. Washer as required. Washer container as required. An automobile wiper motor is a device that powers the windshield wipers, clearing rain, snow, or debris for visibility. It is typically located under the vehicle's hood near the windshield and is controlled by the wiper switch on the dashboard. The motor moves back and forth, activating the wiper arms and blades to sweep across the windshield, improving driver visibility in various weather conditions. Introduction to the wiper system and overview of a car's wiper system components, wiper motor, blades, understanding the importance of a functioning wiper system for clear visibility. Inspecting wiper blades. Close-up of worn, cracked wiper blades on a windshield. Checking the condition of wiper blades for signs of wear and tear. Car windshield being sprayed with water, wipers leaving streaks. Activating the wiper system to the test blade performance in wet conditions. Mechanic lifting wiper arm to adjust blade alignment. Ensuring proper blade alignment for full contact with the windshield. Listening for unusual noises and checking motor operation. Check the wiper switch and blade. Check the wiper washer. Check the electrical wire connections. Check the wiper blade movements. Multimeter measuring voltage at wiper motor terminals. Mechanic checking wiper motor grounding points for corrosion. Ensuring a solid ground connection for the wiper motor. Close-up of worn wiper motor linkage components. Examining the wiper motor linkage for worn or broken parts. Replacing worn blades. Windshield wiper troubleshooting. Serial number, causes, remedies. 1. Wiper blade unserviceable. Replace. 2. Wiper motor not work. Repair or replace. 3. Wiper blade loose mounting. Tighten the mounting. 4. Wiper motor loose fitting. Tighten the loose fitting. 5. Wiper motor gear teeth worn out. Replace the gears. 6. Wiper connecting rod bent. Replace. 7. Wiper motor noise. Repair or lubricate. 8. Wiper motor armature short circuit. Replace armature. 1. No water in washer container. Fill water. 2. Washer operating switch defective. Replace. 3. Washer spray jet nozzles defective. Replace. 4. Water leak in jet nozzle connection. Rectify. 5. Washer water pumping motor defective. Repair or replace. 6. Wire loose connection. Tighten the water connection. Recap.
In this video, we have discussed how to identify the defects in wiper, motor and blades. Hope you have a clear understanding of this. Do this exercise with the help of your instructor.
Thank you.
Hello, I hope you are all excited for today's session. In this module, we are going to learn how to diagnose the power window system for all power window motors do not operate, some switches do not operate.
Objectives. At the end of this video, you shall be able to diagnose the fault in power window, rectify the fault of power window, tools, instruments required, trainee's toolkit, 1 number, equipment required, running car, 1 number, materials required, power window, mounting bolts, washers, cotton waste as required, soap oil as required. A power window is an electrically operated window in a vehicle controlled by switches on the door panel. It replaces manual window cranks with the motor that raises or lowers the window glass. The system includes a motor, regulator and wiring, offering convenient operation for passengers and drivers. Switch on the ignition key. Locate the power window switches. Check the all power window operating switches function. Operate the power window switches one by one. If found switch is defective, replace it. Check the window glass movements or operation. If found the improper operation of power window glass, then check the door glass channels and power window motor. If window glass door channels are unserviceable, replace it. When power window glass operating switch is on but there is no window glass movement, means motor is defective, replace the motor. If motor is running properly but glass is not lifting, means window glass lifting regulator is defective, replace it. Check the power window for external and internal damages. If any major damage in door, replace the door with new one.
Recap. In this video, we have discussed how to diagnose the power window system for all power window motors do not operate, some switches do not operate. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Diagnose the power door lock control for all power door locks do not operate, only one power door lock not operate. Hello, I hope you are all excited for today's session. In this module, we are going to learn how to diagnose the power door lock control for all power door locks do not operate, only one power door lock do not operate. Objectives. At the end of this video, you shall be able to diagnose and service power door lock problems. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainee's toolkit, 1 number. Multimeter, 1 number. Equipment required. Vehicle with power window. Materials required. Door switch as required. Cotton waste as required. Soap oil as required. Power door locks are a feature in modern vehicles that allow the driver or passengers to lock or unlock the doors with the press of a button, often on a key fob or inside the vehicle. Check the door lock fuse. Locate the fuse box in your vehicle. The owner's manual or a diagram on the fuse box cover will help you identify the power door lock fuse. Use a test light or multimeter to check if the fuse is blown. If the fuse is blown, replace it with a new one of the same amperage rating. Inspect the power door lock switches. Remove the door panel where the non-functioning switch is located. Refers to the repair manual for your vehicle for the specific process. Check the power door lock switches for any visible damage, corrosion or loose connections. Use electrical contact cleaner to clean the contacts of the switch. Test power at the switch. Turn the ignition to the on position without starting the engine. Use a multimeter to test for power at the door lock switch. Probe the wires leading to the switch to ensure they are receiving power. If there is power, move to the next step. If not, there may be an issue with the wiring or the main power supply. Check wiring and connections. Trace the wiring harness from the switch to the door jamb where it enters the vehicle. Look for any visible damage, cuts or frayed wires. Check the wiring harness connectors for corrosion, loose pins or disconnections. Repair or replace any damaged wiring or connectors. Test power at the door lock actuator. The door lock actuator is what physically moves the lock mechanism. Remove the door panel to access the door lock actuator. Refer to the repair manual for your vehicle for the specific process. Disconnect the electrical connector from the door lock actuator. Turn the ignition to the on position. Use a multimeter to test for power at the actuator connector while operating the door lock switch. If there is power but the actuator does not move, the actuator may be faulty and needs replacement. Test the actuator. Remove the door lock actuator from the door. Apply power directly to the actuator using jumper wires from the battery. If the actuator does not move, it is faulty and needs to be replaced. Check the door lock rods and mechanism. Sometimes the issue might not be electrical but mechanical. Ensure the door lock rods are properly connected to the door lock actuator. Check for any obstructions or binding in the door lock mechanism. Test additional door lock switches. If only one door lock switch is not working, swap it with a non-working one from another door. If the swapped switch now operates the non-functioning door lock, the original switch is likely faulty. Test the door lock relay. Some vehicles have a power door lock relay that controls the power distribution to the door lock actuator. Refer to the vehicle's repair manual to locate the power door lock relay. Test the relay according to the manual's instructions or replace it with a non-working relay. Reassemble and test. After performing the necessary repairs or replacement, reassemble the door panels and components. Reconnect the battery and test each door lock switch to ensure all door locks operate correctly. Ensure the door panels are securely attached and all components are functioning as they should. Recap. In this video, we have discussed how to identify the defects in wiper motor and blades. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Hello. I hope you are all excited for today's session. In this module, we are going to learn how to diagnose automatic seat belt systems, diagnose airbag system, and service warnings. Objectives. At the end of this video, you shall be able to diagnose the airbag system, service the airbag system, diagnose the seat belt for defects. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainee's toolkit 1 number, spanner set 1 number, scan tool 1 number, screwdriver 1 number. Equipment required. LMV with airbag system. Materials required. Fuse for airbag circuit. Cotton waste as required. Required auto wires as required. Seat belts as required. Seat buckles as required. An automatic seat belt system is a safety mechanism in vehicles that automatically adjusts and secures the seat belt around the occupant when the car is started or in motion. It aims to improve safety by ensuring that occupants are properly restrained in case of a collision. Task 1. Diagnosis of an airbag system. Roll the driver's window down. Turn the ignition switch off and disconnect the negative battery cable. Wait for the time period specified by the vehicle manufacturer. Connect the scan tool to the DLC. under the dashboard. Move the scan tool through the driver's window opening and stand outside the vehicle. Reach into the vehicle and turn the ignition switch on. Be sure there is no one in the vehicle. Reconnect the negative battery cable. Select airbag system on the scan tool and read and record and airbag DTCs. Disconnect the negative battery cable and wait for the time period specified by the vehicle manufacturer. Turn the ignition switch off and disconnect the scan tool. Reconnect the negative battery cable. Task 2. Airbag System Service. Disable the airbag system to prevent accidental airbag deployment on a vehicle with driver's side, passenger side and side impact airbags. Turn the steering wheel until the front wheels are in the straight ahead position. Turn the ignition switch off and remove the ignition key from the switch. Remove the airbag fuse from the fuse block. Note: some airbag system wiring connectors are retained with the Connector Position Assurance (CPA) pin. This pin must be removed before the connector can be disconnected. Disconnect the following connectors: driver's side airbag 2-wire airbag system connector at the base of the steering column. Passenger's side airbag 2-wire connector behind the passenger side airbag inflator module. Driver's side impact inflator module 2-wire connector under the driver's seat. Passenger's side impact inflator module 2-wire connector under the passenger's seat. Perform the necessary service work on the airbag system. Connect all the disconnected airbag system connectors and install the CPA pins in each connector. Install the airbag system fuse. Turn the ignition switch on and check the airbag system warning light for proper system operation. Task 3. Diagnose the seatbelt for defects. Inspect the seatbelts for webbing damage. Extend each seatbelt fully from the retractor. Check the webbing for cuts, broken or pulled threads, cut loops at the belt edge and boved. Replace the seatbelt assembly if any of these conditions are present. Check the seatbelt buckles for damage and proper latching and unlatching. Check the seatbelt retractors for proper operation and proper retention on the vehicle chassis. Inspect the belts for free movement in the tracks if the vehicle has passive seat belts. Confirm the seat belts moves through its complete travel without sticking when the door is opened and closed. Recap. In this video, we have discussed how to diagnose the airbag system, service the airbag system, diagnose the seat belts for defects. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Identify air conditioning components. Performance test on AC unit.
Hello, I hope you are all excited for today's session. In this module, we are going to learn how to identify air conditioning components, performance test on AC unit.
Objectives. At the end of this video, you shall be able to identify all HVAC components of a motor car. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainee's toolkit, 1 number. Spanner set, 1 number. Equipment required. Vehicle with AC. Materials required. Pointer, 1 number. Cotton waste as required. Identify all HVAC components of a motor car. Place the vehicle in park or neutral with the emergency brake set. Raise the hood and disconnect the negative battery cable. Locate the compressor and supporting device. Identify the compressor clutch. Locate the expansion valve and its supporting device. Locate ventilation blower and its support system. Locate filter dryer. Locate high pressure service connections. Locate the pressure switch. Locate the condenser. Locate fan. High pressure pipe in gaseous state. High pressure pipe connection in liquid state. Low pressure pipe connections in liquid state. Low pressure pipe in gaseous state. Performance test on AC unit. Install manifold gauge set. Close high pressure and low pressure valves. Connect the high pressure hose to the discharge service valve of the compressor. Connect the low pressure hose to the suction service valve of the compressor. Run the engine and operate the car AC. Set the blower switch at high speed in AC switch on temperature control at cool and airflow control at vent. Keep all window glasses open. Position the thermometer bulb in cool air outlet. Supply grill outlet. Place psychometer close to the inlet of the cooling unit. Place the psychometer near the cool air outlet. Wait until AC system stabilizes for about 20 to 30 minutes. Check that the reading on high pressure gauge is 14.0 to 15.5 kg by centimeter square, 200 to 230 psi. If the reading is too high, pour water on the condenser. If reading too low, cover the front of the condenser. Check that the reading on the dry bulb thermometer at the air inlet is 25 to 35 degrees Celsius, 77 to 95 Fahrenheit. Check the performance of the air conditioning system. Compare the dry bulb and wet bulb temperature with psychometer chart and dry bulb readings of the psychometer at the air inlet. After measuring the temperature of the wet and dry bulb thermometer at the evaporator air inlet, relative humidity percentage can be obtained. Example, supporting dry and wet bulb temperature at the evaporator air inlets are 25 degrees Celsius, 77 degrees Fahrenheit and 19.5 degrees Celsius, 67 degrees Fahrenheit respectively. The pointer of intersection of the dotted lines in the graphic is 60%. Measure the dry bulb temperature at cool air outlet and calculate the difference between inlet dry bulb and outlet bulb temperature. Check the intersection of the relative humidity and temperature difference between two hatched lines. Recap.
In this video, we have discussed how to identify all HVAC components of a motor car, remote keyless entry system. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Check charged state of refrigerant, inspecting and adjusting an engine drive belt, replacing an engine drive belt.
Hello, I hope you're all excited for today's session. In this module, we are going to learn how to check charged state of refrigerant, inspecting and adjusting on engine drive belt, replacing an engine drive belt.
Objectives. At the end of this video, you shall be able to check the charged refrigerant, check the engine drive belt, replace the engine drive belt. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainees toolkit, 1 number. Equipment required. Vehicle with AC. Materials required. Refrigerant as required. Cotton waste as required. Engine drive belt as required. Compressor drive belt as required. Soap oil as required. Checking the charged state of refrigerant and engine drive belt in a vehicle's air conditioning system is a maintenance procedure aimed at ensuring the system operates efficiently. This involves assessing the level of refrigerant, which is essential for cooling, and inspecting the condition of the engine drive belt, also known as the serpentine belt, responsible for driving various components including the AC compressor. Task 1. Check refrigerant charge. Run engine at fast idle. Operate air conditioner at maximum cooling for a few minutes. Check amount of refrigerant. Observe the side glass on the receiver. Item, symptom, amount of refrigerant, remedy. 1. Bubbles present in side glass. Insufficient. Check for leak with gas leak test. 2. No bubbles present in side glass. None, sufficient or too much. Refer to items 3 and 4. 3. No temperature difference between compressor inlet and outlet. Empty or nearly empty. Evacuate and charge system. Then check for leak with gas leak tester. Refer to items 4. Temperature between compressor, inlet and outlet is noticeably different, proper or too much. Refer to items 5 and 6. 5. Immediately after the air conditioner is turned off, refrigerant in sight glass stays clear. Too much. Discharge the excess refrigerant to specified amount. 6. When the air conditioner is turned off, refrigerant foams and then stays clear. Proper. Task 2. Visual inspection of engine drive belt. Check V-belt tension. A slack V-belt slips, reducing compressor speed and limiting refrigerative capacity. To prevent such trouble, the following pre-inspection is recommended. Push down on the center of the V-belt with the finger and check the distance it moves. This distance varies between vehicles. A worn V-belt must be replaced with a new one of appropriate size and model. Task 3. Check drive belt condition. Visually check the condition of the drive belt. If found damaged engine drive belt, fit the new fan belt and pull the belt and check the tension of the belt. Task 4. Check and adjust belt tension. Check the tension of the belt in comparison with the commented value given in service manual. Measure the tension value using a tension gauge. Normally, the belt running time is about 600 km speed, but if the belt is in good condition, just check the belt for any broken or torn cords or portions. Some cars may have an idler pulley to adjust belt tension. Adjust the idler pulley and accordingly adjust belt tension.
Recap. In this video, we have discussed how to check the charged refrigerant, check the engine drive belt, replace the engine drive belt. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Perform refrigerant recovery, evacuating charging of AC system, replenishing compressor oil level, troubles diagnose and remedy for no cooling or warm air. Cool air comes out only intermittently, insufficient cooling. Hello, I hope you are all excited for today's session. In this module, we are going to learn how to perform refrigerant recovery, evacuating charging of AC system, replenishing compressor oil level, troubles diagnose and remedy for no cooling or warm air. Cool air comes out only intermittently, insufficient cooling. Objectives. At the end of this video, you can able to drain refrigerant in AC system, evacuate refrigerant in AC system, charge the system with refrigerant. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainees toolkit 1 number, owner's repair manual 1 number, socket set 1 number, equipment required. Vehicle with AC, recovery vacuum pump, recovery tank, manifold gauges, materials required. Refrigerant as required. Cotton waste as required. Engine drive belt as required. AC compressor drive belt as required. Soap oil as required. Task 1. Drain refrigerant in AC system. Place the vehicle in park or neutral with emergency brake set. Raise the hood and disconnect the negative battery cable. Place the recovery or recycle machine and plug it into a socket with machine off condition. Hang manifold gauges from the hood in plain view. Connect the high pressure side hose of manifold gauges, normally blue in color, to the low side on your AC. Connect the low pressure side hose of manifold gauge to the low side on your AC line. While connecting the hoses, you must unscrew a small dust cap from the low or high side nozzle and push hose onto the quick release nozzle. Turn on the recovery or recycle machine. Switch on the compressor to the recovery recycling machine. Operate the compressor until the vacuum is indicated on the gauge of recovery or recycling machine. Compressor may shut off, it have automatic shut off feature, otherwise switch off compressor manually. Observe the gauges on the machine for minimum of 5 minutes. If the vacuum rises but remains changes at 0 psi or below, the system is leaking. Repair it after recovery process. If the vacuum reading changes to a pressure above 0 psi, The refrigerant was not completely removed from the system. Then repeat steps above from 5 to 10. If the vacuum holds steady for a minimum 2 minutes, then the recovery is good. Close all the manifold gauge hand valves, service hose valves and recovery system in valve. Disconnect all the manifold gauge and cap all fittings. Task 2. Evacuate refrigerant in AC system. When the refrigerant in the system is discharged or recovered, the system needs to be evacuated. Connect the vacuum pump to the system. Recommended refrigerant oil is to be added before evacuating the system. Use mineral oil for R12 and PAG oil for R134 a system. The oil circulates with the refrigerant through the system. During discharge and recovery, the refrigerant oil is trapped into oil separator during discharging. Drain this oil into a measuring cup and add same amount of oil during evacuating. Switch on the vacuum pump. The vacuum pump pumps out air and creates vacuum, thereby allowing moisture in the system to boil and vaporize. Continued pumping action will remove moisture-laden vapor. The pump may also be attached to the manifold high-pressure side fitting. Close the center hose fitting to which refrigerator container is attached. Switch on the vacuum pump and follow the instructions given in service manual. After the pump has run for about 10 minutes, make a quick check for leakage. Then close both manifold valves, low and high side. Check the vacuum in the gauges. It should not drop more than 2 psi in 5 minutes. If no leak is detected, continue the vacuum pump operation until the entire refrigerant in the system is completely evacuated and the vacuum gauge reads a vacuum of 30 of mercury. Evacuate the system of about 20 minutes after the maximum vacuum is reached. Close off the valves and switch off the pump. The system is now ready for charging the refrigerant. The unit tank must contain a sufficient amount of R134 refrigerant for charging. Check the amount of refrigerant in the tank. If there is less than 3.5 kg, 8 pounds of refrigerant, add new refrigerant to the tank. Refers to the manufacturer's instructions for adding refrigerant. Verify that the high side and the low side hoses are connected to the AC system. Open both the high side and low side valves on the unit's control panel. Open both the gas and the liquid valves on the tank. Refer to the manufacturer's instructions for charging station in use. It is necessary to evacuate the system before recharging it with new or recycled refrigerant. Start the vacuum pump and begin the evacuation process. Non-condensable gases are vented from the tank automatically during the recycling process. You may hear the pressure being released. Check for leaks in the system. Refer to the manufacturer's instructions for charging station in use. Note: change the vacuum pump oil frequently. Refer to the manufacturer's instructions for the charging station in use. Task 3. Charge the system with refrigerant. The system can be charged in many ways: using portable service or charging station, using manifold gauge set and a charging cylinder, using charging station. Connect the charging station vacuum pump to the middle service valve of the manifold gauge and switch on the pump. The refrigerant from the cylinder will flow through the pump and into the compressor suction through the low pressure service valve in the manifold gauge set. Before charging, weigh the cylinder and switch off the charging station once the required quantity of refrigerant is charged. Refer service manual for proper quantity of refrigerant to be added. Some charging stations switch off automatically once the required amount of discharge is done from the charging system. Using manifold gauge set. Connect the charging cylinder with the manifold gauge. Open the valve from the charging cylinder and allow refrigerant to flow through the low pressure side of manifold gauge set. The pressure gauge will show the rise in pressure once the refrigerant flows into the system. The charging cylinder should be weighed before and after charging so that the net change in weight is equal to the quantity of refrigerant to be added. Once charging is over, close all the service valves with caps and disconnect the charging cylinder. The system is now charged with required quantity of refrigerant. Start the vehicle and switch on the AC with blower speed minimum. Note down the temperature readings after about 10 minutes time. Ensure that there is sufficient cooling in the cabin and that all the components are working properly. Take suitable correction action if there is may leak or malfunctioning. Check the compressor running and battery voltage. Check the watch glass of receiver and dryer for proper refrigerant flow. Note: keep the oil bottles tightly capped at all the time to protect the oil from moisture and contamination. You must have an occurred AC vacuum for this operation. Never open the oil injection valve while there is positive pressure in the AC system. This will result in oil blow back through the bottle vent. Never let the oil level drop below the pickup tube while charging or replenishing the system, as this will allow air into the AC system. AC system oil charge replenishing. Any oil removed from the AC system during the recovery process must be replenished at this time. Use the correct graduated bottle of PAG oil for the R134A system. Refer to the manufacturer's instructions for the charging station in use. Add the proper amount of PAG, polyalkyl glycol, oil to the system. Close the valve when the required oil charge has been pulled into the system. Charging. Evacuate the AC system before charging. Close the low side valve on the control panel. Open the high side valve on the control panel. Refer to the manufacturer's instruction for the charging station in use. Enter the amount of refrigerant needed to charge the AC, making sure to use the correct system of measurement, kilogram or pint. Begin the charging process. Recap. In this video, we have discussed how to drain refrigerant in AC system, evacuate refrigerant in AC system, charge the system with refrigerant. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Hello, my name is Marshall. I hope you are all excited for today's session. In this module, we are going to learn how to check abnormal noise from compressor, magnetic clutch, condenser, evaporator, blower motor.
Objectives. At the end of this video, you shall be able to check abnormal noise from compressor, check abnormal noise from magnetic clutch, check abnormal noise from condenser, check abnormal noise from evaporator, check abnormal noise from blower motor. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainees tool kit, 1 number. Decibel meter, 1 number. Car with AC, 1 number. Cotton waste as required. Soap oil as required. Abnormal noises from a car's AC compressor can indicate potential issues within the system, requiring attention to maintain proper cooling performance and prevent costly repairs. Task 1. Check abnormal noise from the compressor. Start the engine and switch on the AC. Ensure the vehicle is parked safely with the parking brake engaged. Start the engine and allow it to idle. Switch on the air conditioning system to its maximum setting. Check the compressor mountings for noise. Listen for any abnormal rattling, clunking or vibration noises from the AC compressor. Inspect the compressor mountings for signs of looseness, wear or damage. If there are noises coming from the mountings, tighten any loose bolts or replace damaged mountings. Check the compressor drive belt tension for noise. Look and listen for squealing, chirping or slapping noises from the AC compressor drive belt. Ensure the belt is properly tensioned. It should have a slight give but not be overly loose or tight. Use a belt tension gauge to measure the tension, adjusting as necessary according to the vehicle's specifications. Check the compressor rotor bearing for noise. Listening for grinding, squeaking or whining noises coming from the compressor. Use a mechanic's stethoscope to pinpoint the source of the noise. Place the probe on the compressor body near the rotor bearing. If there are abnormal noises from the bearing, it may indicate wear or damage, requiring replacement. Check for metallic sounds from the compressor. Listen for metallic clanking, scraping, or knocking sounds. These noises could indicate internal compressor issues such as broken components or debris. If metallic sounds are heard, further investigation is needed, possibly involving compressor disassembly. Check oil level in compressor. Turn off the engine and allow it to cool for a few minutes. Locate the AC compressor, usually mounted near the engine. Identify the compressor's oil fill plug or side glass. Remove the oil fill plug or check the oil level through the side glass. Ensure the oil level is within the manufacturer's recommended range. If the oil level is low, add the appropriate type and amount of compressor oil as specified by the vehicle's manual. Task 2. Check abnormal noise from magnetic clutch. Check the magnetic clutch plate. Listen for any abnormal noises coming from the AC compressor's magnetic clutch area. The magnetic clutch engages and disengages the compressor when the AC is turned on and off. If there are grinding, clicking and rattling noises, inspect the clutch plate for signs of wear or damage. Look for cracks, warping, or own friction material on the clutch plate surface. Check the magnetic clutch bearing. Listen for squeaking, grinding, or whining noises that could indicate issues with the clutch bearing. Use a mechanic's stethoscope to pinpoint the source of the noise. Place the probe on the magnetic clutch housing near the bearing. If abnormal noises are heard, the clutch bearing may be worn or damaged and should be replaced. Check the magnetic clutch mountings. Inspect the mounting bolts and brackets that secure the magnetic clutch to the compressor. Ensure the bolts are tight and the brackets are not cracked or damaged. Loose mountings can cause rattling or vibration noises, especially during AC. Check the magnetic coil power supply. The magnetic coil is responsible for engaging and disengaging the clutch. Inspect the electrical connections to the magnetic coil for any signs of corrosion, damage or loose connections. Use a multimeter to check the power supply to the coil, ensuring it is receiving the proper voltage when the AC is turned on. Check the pulley. Inspect the pulley attached to the magnetic clutch for any signs of wear, damage or misalignment. Rotate the pulley by hand to check for smooth operation. Any grinding, wobbling or rough movement indicates a problem with the puller. The puller should spin freely without any abnormal resistance. Check the air gap between coil and pulley. The air gap between the magnetic coil and the pulley is critical for proper clutch engagement. Use a feeler gauge to measure the air gap as specified by the vehicle's manual. An incorrect air gap can cause abnormal noises and clutch slippage. Adjust the air gap is necessary by loosening the mounting bolts and repositioning the magnetic coil. Check the abnormal noise from condenser. Listen for hissing, rattling or buzzing noises coming from the AC condenser. Inspect the condenser for any signs of damage such as bent fins or leaks. Bent fins can restrict airflow and cause noise, while leaks can lead to refrigerant loss. Address any condenser issues promptly to prevent further damage to the AC system. Task 3. Check abnormal noise from condenser. Check the condenser fins for blockage or damage. Inspect the condenser fins for any signs of blockage, debris accumulation, or damage. Use a flashlight to look through the front of the condenser. Blockages can restrict airflow and cause hissing, buzzing, or rattling noises. Clear any debris using compressed air, a soft brush, or a thin comb. Check the condenser mounting or loose fittings. Inspect the condenser mounting brackets and bolts for tightness and security. Loose or damaged mountings can cause the condenser to vibrate or rattle. Tighten any loose bolts or replace damaged brackets as necessary. Check hose connections for vibration and noise. Listen for any unusual vibrations, rattlings, or hissing noises coming from the hose connections. Inspect the AC hoses and connections for signs of leaks, wear, or damage. Vibrations or loose connections can lead to noise as the AC system operates. Tighten hose clamps and fittings securely to eliminate vibrations. Check for bent or broken fan blades. Inspect the fan blades of the condenser for any bends, cracks, or breaks. Bent or damaged fan blades can cause clicking, scraping, or wiring noises. If blades are damaged, replace the entire fan assembly or individual blade. Task 4. Check the abnormal noises from the evaporator. Check the evaporator fins for damage and noise. Inspect the evaporator fins for any signs of damage, bending, or blockage. Use a flashlight to look into the evaporator unit through the access panel or grill. Damaged fins can cause airflow restriction, leading to hissing, buzzing, or rattling noises. Clear any debris using compressed air or a soft brush, being careful not to damage the fins. Check the evaporator mountings for loose fittings. Inspect the mounting brackets and bolts that secure the evaporator unit to the vehicle. Loose or damaged mountings can cause vibration or rattling noises. Tighten any loose bolts or replace damaged brackets as necessary. Check hose connections for vibration and noise. Listen for any unusual vibrations, rattling, or hissing noises coming from the hose connections to the evaporator. Inspect the AC hoses and fittings for signs of leaks, wear, or damage. Vibrations or loose connections can lead to noise as the AC system operates. Tighten hose clamps and fittings securely to eliminate vibrations. Check for tight fittings of blower coil unit. Inspect the blower coil unit for any signs of loose or misaligned fittings. Loose fittings can cause rattling or vibrating noises during operation. Ensure all connections are securely tightened and aligned with the blower coil unit. Check for bent or loose end blower wheel from the shaft. Inspect the blower wheel inside the blower coil unit. Look for any signs of bending, warping, or looseness of the blower wheel from the shaft. A loose or bent blower wheel can cause clicking, scraping, or wiring noises. If the blower wheel is damaged or loose, it may need to be replaced or reattached securely to the shaft. Task 5. Check the abnormal noise from the blower. Listen for abnormal noise from the blower. Pay attention to any unusual noises coming from the vehicle's dashboard area where the blower is located. Abnormal noises can include rattling, humming, squeaking, or clicking sounds. These noises may change with the speed setting of the blower fan. Check the blower mountings. Inspect the mounting bolts and brackets that secure the blower assembly to the vehicle's dashboard. Loose or damaged mountings can cause vibrations and rattling noises. Tighten any loose bolts or replace damaged brackets as necessary. Check for blower blade contact with the body. Listen for any scraping or rubbing noises that might indicate the blower fan blades are hitting against the blower housing or body. Inspect the clearance between the blower blades and the housing. If the blades are touching the housing, it can create a loud noise and potentially damage the blower. Inspect the blower drive motor mountings. Locate the blower motor usually found inside the HVAC housing, heating, ventilation, and air conditioning. Check the motor mountings and brackets for tightness and security. Loose motor mountings can cause the motor to vibrate, resulting in noise. Ensure the motor is securely fastened to the housing. Recap.
In this video, we have discussed how to check abnormal noise from the compressor, check abnormal noise from the magnetic clutch, check abnormal noise from condenser, check abnormal noise from evaporator, check abnormal noise from blower motor. Hope you have a clear understanding of this. Do this exercise with your instructor. Thank you for watching this video.
नमस्कार, मैं दिव्यांशी चौहान।
नमस्कार, मैं भगवती जबनाल। आप सभी का सीएससी कड़ी की तीसरी चर्चा में आपका स्वागत करते हैं।
हमने अभी तक बात की सीएससी सेवाओं के बारे में